Yeah, welcome back to next lecture in vector calculus. That's Gauss divergence theorem. This is related to surface and volume integral. It is a relationship between surface and volume integral. Let's see the statement. If f vector is a continuously differentiable vector function in the region capital R bounded by the closed curve C, closed curve S, then surface integral f dot n cap ds, I have already discussed surface and volume integrals, is equal to the triple integration over region R del divergence of f dv. dv we can say like that. If you want, you can like also like this: divergence of f vector, and dv is dx dy dz. It's a volume element. dv is dx dy dz, where n cap is the unit external normal vector. External normal vector. Let's see the one problem. How to solve any surface integral using Gauss divergence theorem. Verify divergence theorem for f vector equal to x square minus yzi plus y square minus zxj plus z square minus xy k cap, taken over the rectangular parallelopiped 0 less than x less than e, 0 less than y less than equal to b, and 0 less than z less than equal to c. Let's see the solution. Firstly, I am going to draw the parallelopiped, so the problem will become easy. It is a very easy way to draw a parallelopipe, to draw the two rectangles and meet them like this. Then extend these sides, it will become coordinate axis. It will become coordinate axis. This is x-axis, this is y-axis, this is z-axis, and this is origin O. This is any point P I am taking. This is A coordinate, suppose. This is B coordinate. This is C coordinate. This coordinate I am taking as B dash. This is coordinate I am taking as A dash. And this coordinate I am taking as C dash. We know that in any rectangular parallelepiped or cuboid actually, there are 6 surfaces. What are the 6 surfaces? Can you tell me? If you take the entire surfaces S, then this is union of 6 surfaces actually. Where S1, S2, S3 look like this. S1, I am taking OAC dash B. S2, I am taking CB dash PA dash. O A C dash B. This is the first surface S1 I am taking in XY plane, downward XY plane. C B dash P A dash is XY in outside direction. S3 O B A dash C. O B A dash C. This back side of XZ axis. X4 A C dash P B dash. A C dash P B dash. S5 it is O C B dash A. O C B dash A. And S6 is actually here BA dash PC dash. Now, what are the normal vector for these six surfaces? These are all 2D surfaces. If you mix these all six surfaces, you will get a 3D rectangular parallelepiped. So, now all these are 2D surfaces. If you see OAC dash B, OAC dash B, it is in XY plane backward direction. So in XY plane, outward vector should be k cap, but it is in backside. So direction of outward vector will be direct opposite. So it will be minus k cap. Here C B dash P, it's a outside in XY plane. This is parallel to x axis. This is parallel to y axis. So outward normal vector is k cap. OB A dash C. OB A dash C in the XZ plane backside. So n cap will be minus j cap. AC PB dash n cap equal to plus j cap. OCB dash n cap equal to minus I cap. And n cap will be the plus I cap. I am going to tell you a small trick. If O is included in any surface, origin is included, it means you are in backside. So always unit vector will be in with negative sign. Take my hint, you will get a lot of help. Otherwise, it will be positive. Okay? Or you can say P point is there. P point is there. You will get positive due to this point. This is actually outside point. Origin is inside point. Okay, this is the hint for it. Now, we will evaluate this integral, surface integral, f dot n cap ds. That is equal to the sum of all surfaces. Sum of all surface integrals. So on S6 f dot n cap ds. Now, let's see one by one. Firstly, I am going to find f dot n cap. F is given as x square minus yz iota plus y square minus zxj plus z square minus xyk. Now I am taking for first surface S1. S1 is first surface as OAC dash B and cap is minus k cap and origin is included. It's the back side of xy plane. So z equal to 0. Z equal to 0. If you see in this plane z equal to 0, but it's a front like this plane. This is the outside plane of xy. Z is not 0, it is 0, comma 0, comma c. Here it is 0, comma 0, comma 0. So if you take second plane, z will be c, that is fixed actually. But in this case, z equal to 0. So dz equal to obviously 0. So f dot n cap will convert as now z equal to 0 if you put x square I plus y square j minus xyk. Now dot product with minus k cap. It will be plus xy only. Plus xy only. So f dot n cap ds is equal to plus xy. ds is nothing else. It's a dx dy over. Now, see carefully here. ds is actually dx dy over in xy plane. You are dealing in xy plane n dot k cap. Here k cap is negative minus k cap. So this is minus k cap into k cap. So it will be minus dx dy. So it will be minus dx dy. Now, if you see in the xy plane, actually, x is from 0 to a because the value is 0, a comma 0, and this is 0, 0, b. So x is from 0 to a, y is from 0 to b, minus sign we can take outside x, y, dx, dy. If you compute it, you will get minus a square b square by 4. Minus a square b square by 4. Similarly, if you take the S2 surface, that is CB dash PA dash, your N cap is actually plus K cap and Z is fixed there because you are getting height. That height is constant, Z equal to C. But dz is going to be 0 again because derivative of C is 0. So the second surface integral, if you do f dot n cap ds, here ds will become dx dy over n dot k cap. So ds will become dx dy. Limit of x and y are fixed 0 to a and x 0 to a and y is from 0 to b. F dot n cap. Here f dot n cap is little bit important because if you take this, then f dot n cap, I'm going to solve this. It will be x square minus czi, cyi, because z is j, na? Z is c, plus y square minus zx means cxj, plus c square minus xyk. And if you take the dot product with k cap only, you will get c square minus xy. This is your f dot n cap here. And dx dy. If you simplify it, you will get abc square minus a square b square by 4. This is your second double integration. Second integration for surface 2. Similarly, if you solve for S3 f dot n cap ds, I am telling you it will be yeah, important point is here we missed little bit calculation error here. Actually, if you are taking, this is actually telling the opposite direction. You are in xy plane only, but if you are taking in opposite direction, then you have to take only one time negative sign. I am taking twice. If you are taking with negative sign here minus k cap, then here you have to take plus sign. So the better way is, if n cap is minus k cap, it is for only surfaces. When your x-axis is perpendicular to yz plane, y is perpendicular to zx, and z is perpendicular to xy. Then n cap is I, j, k, minus I, minus j, minus k. That is actually telling the negative direction. But if you are taking two time negative, na, it will become same direction. So I did the same mistake, minus k cap and minus k cap two places. So it is obviously same thing. So it will be, I will advise if you always write dx dy here. Don't do this calculation. If you have already taken the opposite direction, then ds is fixed now. That will be, ds is fixed now for this. ds will be dx dy. This is in outward direction, this is inward direction. Here ds will be dx dz. Here ds will be dy dz. Don't be confused for both. Actually, one is telling opposite direction and another is telling same. One direction is outward, one is downward by inward. So it will be minus minus plus actually. So it will be plus a square b square by 4. This made this correction carefully. Okay. Similarly, you will get this value is b square c square by 4. For surface 4, you will get at f dot n cap ds is equal to a square bc minus b square c square by 4. For surface 5, you will get f dot n cap ds is equal to c square a square by 4. And for surface 6, you will get f dot n cap ds is equal to ab square c. If you add for S is sum of all these surfaces, you will get a square bc plus ab square c plus ab square c. If you take the common, it is abc a plus b plus c. This is by surface integral. Now using Gauss divergence theorem, you will see the problem is quite easy if you use the theorem. So we have to find the surface integral f dot n cap ds is equal to the triple integration of region R divergence of f dv. So we will find a divergence of f, that is del by del x x square minus yz plus del by del y y square minus zx plus del by del z z square minus xy. So you will get this is twice x plus y plus z. You put this value 2x plus y plus z, and very important point is here the closed region is actually cuboid and sides are parallel to the axis. Bounded region sides are parallel to the axis, then all the three limit will be constant. So x will be from 0 to a, y will be from 0 to b, z will be from 0 to c. If you simplify it, you will get a b c, a plus b plus c. Same answer you will get. Same answer you will get. Next example 2. Evaluate the surface integral f dot n cap ds. Evaluate means verification is not needed here. Only you can apply the Gauss divergence theorem directly, where f vector is 4xi minus 2y square j plus z square k. This is important question, and I will tell you very small trick for this. And S is the surface bounded by the region x square plus y square equal to 4, z equal to 0 and z equal to 2. This is actually cylinder. Look like it's a circle here, and you are giving the height to the cylinder up to z equal to 2. So this is z equal to 2. This is z equal to 2, 2, 0, 0, 2. This is xy plane, and it is a cylinder, and the base of the cylinder is a circle. Okay. So we will find firstly divergence of f. That will be del by del x of 4x plus del by del y of minus 2y square plus del by del z of z square. So we will get this is 4 minus 4y plus 2z. Divergence is a function of y and z. Y and z. Okay. Now, so the surface integral f dot n cap ds is equal to, we know that over the region R, it's a divergence of f dv, and it is equal to now 4 minus 4y plus 2z. I'm going to evaluate for z firstly, dz dxy, and we know the limit of z is from 0 to 2. So solve firstly it. 0 to 2 integration you solve. You will get this is 12 minus 12y plus 9 dx dy. Now you are in xy plane. XY plane, that is 21 minus 12y dx dy. In xy plane, actually, it is a circle. X square plus y square equal to 4. And you have double integration. So x and y both will be in two parameter. X equal to r cos theta, y equal to r sin theta. So this integral become now 21 minus 12 r sin theta, and dx dy is r dr d theta. Change the order of integration, change the variable of integration. Always remember, if you are in single integration, then radius will be fixed 2 cos theta, y will be 2 sin theta. But if you are double integration, r and theta both vary. Can you tell me the theta? Theta will be from 0 to 2 pi, entire circle. But if you see the radius is, because you are in 2D picture, if you draw the radius, you have to take from pole actually, r equal to 0. Minimum limit of r is 0 always. And it is x square plus y square is 4. So r square equal to 4, r equal to plus 2. We cannot take negative because the radius is always positive. So r will be from 0 to 2. Now if you integrate firstly with respect to r, it will be 21 integration r equal to 0 to 2, 21r minus 12r square sin theta dr d theta. So if you solve for r, you will get 21r square by 2 minus 12r cube by 3 sin theta 0 to 2 d theta. And then you solve for theta after applying the limit in r, you will get the answer is 84 pi. 84 pi. So this is the ending of Gauss divergence theorem and ending of vector calculus unit. Okay, thank you.